lesson two conditional statements. We're going to learn how to recognize conditional statements and their parts, and we're going to learn how to write converses, inverses, and contrapositives. A lot of new words. Pay attention to the vocab, and you will have to know all these things. Go ahead and do the review. All right, here's a key concept, conditional statements. And conditional is an if-then statement. The hypothesis is the part following the if, and the conclusion is the part following the then. And this is the shorthand way of writing that. The P means the hypothesis, the Q means the conclusion. And you can write it some different ways and say it some different ways. Go ahead and see if you can answer number 6, the 2 ways to write it. Okay, so remember from the key concept that the hypothesis is the part that follows the if, and the conclusion is the part that follows the then. So a number is even is the hypothesis, and it is divisible by 2 is the conclusion. Go ahead and see if you can identify the hypothesis and conclusion in the next problem. Notice in the answers here that I did not circle the word if. I did not underline the word then. That is not included in the hypothesis or the conclusion. All right, writing a conditional. How can you write the following statement as a conditional? Adjacent angles share a side. So what you have to think about is what is the conclusion here? What is the hypothesis? And I think the conclusion here is that the adjacent angles will share a side. That's the conclusion. So the hypothesis is that you have adjacent angles. So if, and I'm going to add the word 2 here, if 2 angles are adjacent, then the 2 angles share a side. All right, I'll let you try that. Okay, so a conditional statement can either be true or false. If it's false, all you have to do to show that is find a counterexample. So looking at this first statement here, if you live in Miami, then you live in Florida. I'm going to say that's false. And my counterexample for that is you could live in Miami, Ohio, and you wouldn't live in Florida. So my counterexample is you live in Miami, Ohio. And the second statement, if a number is divisible by 5, then it is odd. So let's just look at numbers divisible by 5. That's these numbers. And if I divide, so all these are divisible by 5, but we know that 10 and 20 and 30 are even, so that would be a counterexample to this, so we're going to say false. 10 is divisible by 5, and it is even. All right, go ahead, you try that. All right, here's where we're going to learn how to write different versions of these conditional statements, and you have to know all these. The original conditional statement, the converse, and that's where you just exchange the hypothesis and conclusion. The inverse, that's where you negate both the hypothesis and the conclusion, and that's what this symbol right here means not. So that the way you say this, if not P, then not Q. And the contrapositive is negating both the hypothesis and conclusion of the converse. Okay, so go ahead and see if you can think about those definitions and rewrite these here. So here's the answers, and some of you probably noticed that some of these answers don't really make sense, and you can change the truth value by changing something from, say, it's conditional to its converse. So you have to keep that in mind. You may or may not. Okay, so what are the converse, inverse, and contrapositive of the conditional statements below? So you're going to turn this statement into its converse, its inverse, and its contrapositive. Okay, so here are the statements, and now let's talk about whether they're true or not. The original statement, if a figure is a rectangle that is a parallelogram, that is true. All rectangles are parallelograms because their opposite sides are congruent, which is true of all parallelograms. And the second statement, the converse, so we're talking about this now, if a figure is a parallelogram, then it is a rectangle. And we're going to say that's false because rectangles need 4 90-degree angles, and you can have a parallelogram that looks like that, where opposite sides are congruent, but you do not have 4 90-degree angles. So that's false. The next statement, the inverse, if a figure is not a rectangle, then it is not a parallelogram. That's also false because of the same reason. We can have a figure like this that is not a rectangle and is a parallelogram. So the last statement, if the figure is not a parallelogram, then it is not a rectangle. That's true because if it's not a parallelogram, then that means it doesn't have opposite sides that are congruent. So, and if that's not true, then it can't be a rectangle. So the last statement is true. All right, so you try and write some of those and see if you can't figure out whether they're true or false. You may have noticed a little pattern in here that, and this is really always true, if the converse is, whatever truth value the converse have, the inverse will have the same truth value, and whatever truth value the original statement has, the contrapositive will have the same truth value. That's always true. All right, that's it for the lesson today. You can go ahead and do the lesson check and get ready for tomorrow. And I will see you in class.